National Electrical Code Section 404.14c addresses the use of dimmers in electrical circuits, specifically concerning receptacles connected to dimmers. This section of the code aims to prevent overloading of dimmers and ensure safe operation of electrical systems. The specific requirement states that receptacles connected to a dimmer shall not supply a total load in excess of 80% of the dimmer rating. This means that the total current drawn by any devices plugged into the receptacle must not exceed 80% of the maximum current that the dimmer is designed to handle. For example, consider a 15 amps dimmer. According to the 80% rule, this dimmer can only safely handle a load of up to 12 amps, calculated as 0.80 times 15 amps equals 12 amps. If the receptacles connected to this dimmer draw more than 12 amps, the dimmer could overheat, malfunction, or pose a fire hazard. To illustrate this point, let us examine the scenario of a 125 volts, 20 amps duplex receptacle connected to a dimming pile. The power consumed by a 20 amps receptacle at 125 volts is calculated by multiplying the voltage by the current, which is 125 volts times 20 amps equals 2500 watts. This means that the receptacle is capable of supplying up to 2500 watts of power to connected devices. However, if this receptacle is connected to a 15 amps dimmer, it is likely to exceed the dimmer's capacity. A 15 amps dimmer at 125 volts can only handle 1875 watts, calculated by multiplying 15 amps by 125 volts. According to the NEC requirement, the receptacle should not supply a load exceeding 80% of the dimmer's rating. In this case, 80% of 1875 watts is 1500 watts, calculated as 0.80 times 1875 watts equals 1500 watts. Since the 20 amps receptacle can potentially draw 2500 watts, which is significantly more than the 1500 watts limit, it is a violation of NEC 404.14c. This is because connecting a 20 amps receptacle to a dimmer that cannot handle the potential load creates a risk of overloading the dimmer and causing it to fail. The NEC 80% rule is in place to account for continuous loads. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. The NEC requires that overcurrent protection devices, such as circuit breakers and fuses, as well as conductors and equipment, be rated for at least 125% of the continuous load. This is equivalent to limiting the load to 80% of the device's rating. For example, if a circuit is expected to carry a continuous load of 16 amps, the circuit breaker should be rated for at least 20 amps, calculated as 1.25 times 16 amps equals 20 amps. This ensures that the circuit breaker will not trip due to the continuous load and that the conductors and equipment will not overheat. In the case of dimmers, the 80% rule ensures that the dimmer is not subjected to a continuous load that exceeds its capacity. This helps to prevent the dimmer from overheating and failing prematurely. The NEC also specifies requirements for the type of dimmers that can be used with receptacles. For example, some dimmers are designed to be used only with specific types of loads, such as incandescent lamps or LED lamps. Other dimmers are designed to be used with a wider range of loads. It is important to select a dimmer that is compatible with the type of load that will be connected to the receptacle. In addition to the 80% rule, the NEC also includes other requirements for dimmers. For example, the NEC requires that dimmers be installed in accordance with the manufacturer's instructions. This includes ensuring that the dimmer is properly grounded and that the wiring connections are made correctly. The NEC also requires that dimmers be protected from overcurrent. This can be accomplished by installing a circuit breaker or fuse in the circuit that supplies power to the dimmer. The size of the circuit breaker or fuse should be selected to protect the dimmer from overload, but it should not be so large that it allows the dimmer to be damaged by a short circuit. Furthermore, the NEC addresses specific applications where dimmers are used, such as in theaters and other entertainment venues. These applications may have additional requirements for dimmers, such as the need for dimmers to be listed for use in these locations. Compliance with NEC 404.14c is crucial for electrical safety. Overloading dimmers can lead to overheating, insulation breakdown, and potentially electrical fires. Adhering to the 80% rule ensures that dimmers operate within their safe thermal limits. In summary, connecting a 125 volts 20 amps receptacle to a dimming panel is generally a violation of NEC 404.14c because the receptacle's potential load exceeds the dimmer's capacity. It is essential to ensure that the total load connected to a dimmer does not exceed 80% of its rating to prevent overheating and ensure electrical safety. Therefore, it is important to carefully consider the load requirements of any devices that will be connected to a receptacle before connecting it to a dimming panel. If the load requirements exceed the dimmer's capacity, a different type of control device should be used, such as a switch or a relay. By following these guidelines, it is possible to ensure that electrical systems are installed and operated safely. National Electrical Code, or NEC, is a set of standards published by the National Fire Protection Association, or NFPA, for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years. Compliance with the NEC is mandatory in many jurisdictions. NEC Section 404 pertains to switches, dimmers, and control devices. It provides detailed requirements for the installation and use of these devices to ensure electrical safety and proper operation. Section 404.14 specifically covers dimmer switches. It outlines the requirements for the types of dimmers that can be used in various applications, as well as the installation and wiring methods. Dimmers are commonly used to control the brightness of lighting fixtures, allowing for energy savings and creating different lighting moods. However, it is crucial to select and install dimmers correctly to avoid potential hazards. The NEC provides guidance on various aspects of dimmer installations, including the types of loads that can be connected to dimmers, the wiring methods that must be used, and the overcurrent protection requirements. Different types of dimmers are available on the market, including incandescent dimmers, LED dimmers, and fluorescent dimmers. Each type of dimmer is designed to work with specific types of lighting fixtures. Using the wrong type of dimmer can result in flickering, reduced lamp life, or even damage to the dimmer or the lighting fixture. The NEC requires that dimmers be listed and labeled for the intended use. This means that the dimmer has been tested and certified by a recognized testing laboratory to meet safety standards. The listing mark on the dimmer indicates that it has been evaluated for specific applications and load types. When installing dimmers, it is important to follow the manufacturer's instructions carefully. The instructions provide detailed information on the wiring methods, mounting requirements, and other installation considerations. Improper installation can lead to electrical hazards such as short circuits, overloads, and fires. The NEC also addresses the use of dimmers in specific locations, such as bathrooms and wet locations. These locations may require the use of special dimmers that are designed to be resistant to moisture and corrosion. In addition to the requirements for dimmers, the NEC also includes requirements for the wiring of lighting circuits. These requirements cover the types of conductors that must be used, the wiring methods that must be followed, and the overcurrent protection requirements. Proper wiring is essential for ensuring the safety and reliability of lighting circuits. The NEC also includes requirements for the grounding of electrical systems. Grounding is the process of connecting the metal parts of electrical equipment to the earth. This helps to protect against electrical shock and reduce the risk of fire. The NEC provides detailed requirements for grounding systems, including the types of grounding electrodes that must be used, the size of the grounding conductors, and the methods for connecting the grounding conductors to the equipment. In summary, the NEC is a comprehensive set of standards that provides guidance on the safe installation of electrical wiring and equipment. Compliance with the NEC is essential for ensuring the safety of people and property. When working with electrical systems, it is important to consult the NEC and follow the instructions of qualified professionals. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Electrical work can be dangerous and should only be performed by those who are trained and experienced in the field. By following the NEC and working with qualified professionals, it is possible to ensure that electrical systems are installed and operated safely.